So the sodium, by losing one electron, becomes a sodium plus, and it gets the electronic configuration similar to that of an ion. And the chlorine gains one electron, and it becomes 3s2 3p6 electronic configuration, which is similar to that of argon electronic configuration. So what happens? So by losing one electron, sodium has attained stability. By gaining one electron, chlorine has attained stability. So the sodium plus and Cl minus, a cation and an anion, there is an electrostatic attraction. And because of this electrostatic attraction, sodium plus and Cl minus ions are together, and the attraction, which is the bond formed between these two ions, is called ionic bond. And also the X-ray spectroscopy proves that in the solid state itself, sodium and chlorine are present in the form of a sodium plus ion and a Cl minus ion. So the number of electrons lost or the number of electrons gained to occur the stable electronic configuration is called electrovalency. And also, if you take a chlorine ion, chloride ion, the minus charge is found all around the chlorine atom. If we take a sodium plus ion, the plus charge is found all around the sodium plus ion. Therefore, I can say this electric field is non-directional electric field. So the ionic bond is also non-directional. It may be in all directions. It is a non-directional bond, and the electric field is also non-directional. So these are all the important idea about the ionic bond. So look at the next one. Even in the dot diagram, I can explain like this. See, look here. The electron of the sodium is mentioned as a dot, where the electrons of the chlorine are mentioned as a crosses, just for you to understand. Now this dot has gone to chlorine. Now, so chlorine now has 8 electrons in the outermost cell. Therefore, totally it has one minus charge, but the sodium has lost its one electron. So it becomes a sodium plus ion. So this is how it is diagrammatically explained. Now, if you see the formation of the calcium fluoride, the ionic bond formation between calcium and the fluorine. Look at the electronic configuration of a calcium. Calcium is with the atomic number 20, and the calcium has the electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. And the calcium can attain the noble gas electronic configuration when these two electrons are lost. So when they are lost, the electronic configuration becomes a 3s2 to 3p6, which is exactly as that of a noble gas. Similarly, if you take a fluorine, whose atomic number is 9, the electronic configuration is 1s2, 2s2, 2p5. When it gains one electron, it becomes a 2s2, 2p6, which is like a noble gas electronic configuration. So calcium is ready to lose 2 electrons. Fluorine is ready to accept 1 electron. So what happens? 2 fluorine atoms accept the 2 electrons, and the compound formation is like this. Look here, the calcium electrons are mentioned as dots, whereas the fluorine electrons are mentioned as crosses. So I take 2 fluorine atoms, each with 7 electrons in the outermost shell, whereas calcium is with 2 electrons. So one of these 2 electrons goes to one fluorine atom, and the other electron goes to the other fluorine atom, and the compound is formed like this: calcium 2 plus and F minus and F minus. Even this bond is also non-directional. This is non-directional because this fluorine can come here, this fluorine can go there, it can be anywhere, because the electric field is non-directional and the ionic bond is also non-directional. So this is about the calcium fluoride. If you take a magnesium sulphide is another interesting compound in which magnesium has the atomic number 12. So its electronic configuration is 1s2, 2s2, 2p6, 3s2. So Magnesium attains the noble gas electronic configuration when it loses the 2 electrons in the 3s orbit. So 3s orbital. So when the 2 electrons are lost, it becomes a 2s2 2p6, which is similar to that of, identical to that of noble gas electronic configuration. If you take sulfur, sulfur is with the atomic number 16 and the electronic configuration is 1s2 2s2 2p6 3s2 3p4. Look at the outermost electronic configuration, s2p4. This is stable when it becomes s2p6. So it needs 2 more electrons to attain stability. So look here. So it has 4 electrons. Here 2 electrons are missed, I have not written. Sulfur has 6 electrons in the outermost shell. And the magnesium gives the 2 electrons to that. And totally it gets a completed octet. So the 2 electrons are completely transferred from magnesium to sulfur. Thus the ionic bond is formed. So magnesium becomes a 2 plus and the sulfur becomes a 2 minus. So there is an electrostatic attraction between the magnesium 2 plus and sulfur 2 minus, and the ionic bond is established. So this is how the ionic bond between atoms have been formed.